Hello, my name is Ryan Hunter.
I'm Drew Morris.
I'm Mike McManus.
I'm Wes Wheat.
And I'm John Burke.
And we're Emagine.
One of the main obstacles in our design is being able to distinguish signals of interest from the noise. And one of our main techniques we'll be implementing to do this is increasing the sampling frequency. And as you increase your sampling frequency, you'll effectively see your noise floor reduced, thus being able to pick out your signals of interest more easily.
So these are the results of the MATLAB simulation. On the left, this is our pure sinusoid. The middle one is with the noise added to it, and the third one is the result of the FFT. This is the slowest sampling rate. As you can see, the noise is still very present. As we increase the frequency of the sampling, you can see the noise floor dropping significantly, leaving the intended signal to be pulled out more distinct as we go forward. 800 kilohertz, it's very, very distinct. Could almost chop that off. And finally at a megahertz, it's as clear as day. And once we apply filtering to the noisy signal, the signal will only become more and more distinct.
Hello and welcome to Test 3. In this test, we will be demonstrating both the logging functions or logommatic as well as the signal processing suite shown here. First, I'm going to begin by describing our electronics test configuration. For our test configuration, we have a logommatic data recorder, as shown here. This logommatic recorder has the ability to record test data from an A to D converter and put it on an SD card that we will later use for post-processing.
We're inputting two signals. We have one here at 121 hertz, 1.6 volts, and a 1.1 volt offset. And the second one has 230 hertz frequency, 1.2 volt, and a 1.1 volt offset. And they're both sinusoidal waves, and the point of the two different waves is to show that our FFT will show two spikes, one at 121 hertz and one at 230 hertz.
To begin the test, we simply turn on the data logger. The blinking lights indicate that it is currently recording data. When we are done recording, we hit the stop button, which stops the recording, and we move on to the next part.
Now we're going to take the data from the test and input it into the computer. Alright, now we'll be showing the FFT of the data that we took. And here we can see that we have two visible spikes, at one at 121 hertz and one at 230 hertz, and I can zoom in on those to show you a better view of that. Here is the spike at 121 hertz, and then you can also go zoom back out and see the spike at 230 hertz. This test shows the functionality of our data logging hardware and our post-processing suite.
Thank you for watching.